Most housing is still built like it was a century ago, slowly, on-site, exposed to weather, delays, and labor bottlenecks. But in the most advanced urban prototypes, the construction site is starting to disappear. The building arrives already made. Walls come out of automated factories with insulation, wiring, and sensors embedded inside them. Bathroom cores arrive complete. Facade panels are lifted into place by robotic cranes and guided by machine vision, instead of chalk lines and guesswork. What used to take months of coordination can start looking more like high-precision assembly. That changes more than speed. It changes the economics of cities that are growing faster than conventional construction can respond. Housing can be added in smaller increments, on tighter lots, and with far less waste. Damaged modules can be replaced instead of demolished. Entire neighborhoods can adapt block by block instead of waiting for one giant project to finish. The interesting part is not the factory itself. It is the urban system around it. Zoning that accepts modular formats, logistics networks designed for giant components, robotic staging yards at the city edge, and software that treats homes almost like upgradable products. Of course, fast housing is not automatically good housing. Repetition, affordability, ownership, and design quality still matter. But once homes can be manufactured with the precision of vehicles, and deployed with the speed of infrastructure, the city stops expanding only through slow construction. It begins to grow through production. Neon Atlas. Mapping the cities of tomorrow.